Give a reasoning model hands and something changes. Last episode, you watched a model learn to think before it answers, spending a long internal chain of reasoning on a hard, verifiable problem. Now do the obvious next thing. Because there is a category of AI that has genuinely changed how software gets built, and there is a decent chance one of them helped build the very pipeline that rendered this course. I am talking about AI coding agents. Tools like Claude Code, living in your terminal, and Cursor, living in your editor. And here's the thing people miss about them. They are not fancy autocomplete. You already learned about autocomplete implicitly, a model predicting the next token. A coding agent is a completely different animal, and the difference is the whole point of this episode. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. Here's the idea in one sentence. An AI coding agent is a reasoning model wrapped in a loop that lets it read your code base, take actions like editing files and running commands, observe what happened, and keep going until the job is actually done. Read that carefully because it is just the agent loop we spent whole episodes on earlier in the course. Reason, act, observe, repeat, pointed at one specific and incredibly useful domain, your code. The model does not get your entire project handed to it. It works the way a new engineer on their first day would. It explores. So let me walk you through what actually happens when you type a request like, fix the bug where logging out does not clear the session. The agent does not magically know where that code lives. It runs a real software engineering workflow, and researchers who build coding benchmarks describe it in almost exactly these steps. First, read the issue, understand what you are actually asking. Second, explore the code, and this is the crucial part, so pay attention. A serious code base might be 100,000 lines or more. That does not remotely fit in the context window, and you learned back in the context window episode why there is a hard limit on how much the model can hold at once. So the agent cannot just read everything. Instead, it acts like a developer with a search tool. It greps for the word session. It opens the files that look relevant. It follows the function that handles logout. It builds up, piece by piece, just the slice of the codebase it actually needs, pulling the right context into its window, and leaving the millions of irrelevant tokens out. Third, it localizes the change, pinpointing the exact function and line. Fourth, it makes the edit. And fifth, and this is what separates a real agent from a toy, it verifies. It runs the tests. It runs the code. And if something broke, it reads the error, reasons about it, and goes back and fixes it, looping until it is actually green. Now I want to zoom in on one mechanical detail that matters more than people expect: how the agent actually changes your file. A naive approach would be to have the model rewrite the entire file from scratch and paste it back. That is slow. It burns a fortune in tokens on a big file, and worse, the model might accidentally change a line you never wanted touched. So good coding agents do not do that. They apply a diff, a surgical patch. The model outputs something that says, in this exact file, find this precise block of existing text and replace it with this new text. Just the changed lines, matched against what is already there. It is the same discipline a human uses with version control. A small reviewable change instead of a wholesale rewrite. And it is a big part of why modern agents can edit 10 files across a project without turning the whole thing to mush. And how good is this, really? The honest answer is, on the right kind of task, startlingly good, and we can put a number on it because there is a benchmark built for exactly this. It is called SWE-bench, and specifically a cleaned-up version called SWE-bench Verified. It takes real bugs from real open-source projects, actual GitHub issues, hands the agent the repository, and checks whether the fix the agent writes makes the project's own tests pass. This is not a toy quiz. It is real software engineering work. And as of this recording, the top agentic models built on the latest Claude and its peers are solving well over 90% of these verified tasks. A couple of years ago, that number was a fraction of what it is now. That is a real, measurable leap in a very short time. But because this is a course that respects you, Let me be honest about where it breaks, because it absolutely does. The biggest failure mode has a name that has caught on: context rot. Remember, the agent is accumulating context as it works. Every file it read, every command it ran, every error it saw, all piling up in its window. On a long, sprawling session, that window gets stuffed with a huge, messy history, and the model's performance quietly degrades. It starts to lose the thread, forget a decision it made 20 steps ago, or get distracted by something irrelevant it read an hour earlier. This is why experienced people work with these agents in tight, well-scoped chunks rather than one marathon session. And why a lot of the engineering behind these tools is really about managing what stays in the context window and what gets summarized or dropped, which, if you took the memory episodes in this course, should sound very familiar. There is also the matter of how the agent reaches the rest of your world, your database, your issue tracker, your documentation, and that is where the model context protocol you learned about comes back. MCP is often how a coding agent plugs into tools and data beyond the raw files on disk. So how does this land, depending on who you are? As an individual developer, a coding agent is the most powerful lever you have ever had. You delegate a whole chunk of work in plain English and get back a real, tested change. But the skill is learning to scope your requests tightly and review every diff, because you are the senior engineer now, and the agent is your fast, tireless, occasionally overconfident junior. As a startup, these tools genuinely compress how fast a small team can ship. One common pattern in 2026 is developers running an editor agent like Cursor for tight line-by-line work and a terminal agent like Claude Code for larger, goal-level tasks like a multi-file refactor, letting a tiny team move like a much bigger one. And as a large enterprise, the promise is enormous, but so is the caution. Coding agents can chew through the backlog of small fixes and migrations that no one ever gets to. But you wrap them in the same guardrails, reviews, tests, and permissions you learned about earlier, because an agent that can edit code and run commands is an agent that can do real damage if you let it act unsupervised. So let us bring it home. An AI coding agent is not autocomplete. It is a reasoning model in a loop, reading an issue, exploring a codebase far too big to fit in its context, localizing the change, applying surgical diffs instead of rewriting whole files, and verifying its own work by running the tests measured on real bugs by benchmarks like SWE-bench Verified, where the best agents now clear 90% and held back mostly by context rot on long sessions. It is the agent loop from earlier in this course, given hands and pointed at software. And notice what just happened. We gave the model a very specific set of hands, editing files and running commands in a terminal. But what if we took the restraints off entirely? What if instead of a codebase, we gave the model a screen, a mouse, and a keyboard, and let it use any application a human can? That is the frontier, and it is where the bonus round goes next. Computer use agents. The model's learning to operate your computer the way you do, one screenshot and one click at a time. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.